Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the voltage to current converter by using operational amplifier. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the current to voltage converter by using operational amplifier. We know that our op amp is used for many purposes like addition, subtraction, integration, derivation, etc. Okay. Here, the op amps are also used to convert voltage to current and current to voltage. Now, in this video, we are going to see the op amp as an current to voltage converter. The current to voltage converter is special case of inverting amplifier. It is also called as the current controlled voltage source. The current to voltage converter is shown in this circuit diagram. If we see the circuit diagram, then we can clearly understand that here the non-inverting terminal, that means plus terminal, is simply connected to the ground, and the input supply V in is connected to the inverting terminal. Hence, this is the inverting type application or configuration. That means we can say that the current to voltage converter is a simply inverting amplifier, and we know that the gain of the inverting amplifier is minus RF upon R in or R1. Okay, here in current to voltage converter, the input quantity is the current and the output is its proportional voltage. Okay, in this diagram we can see V in is connected to inverting terminal through resistor R1. Here I in is the input current. Similarly, RF is the feedback resistor which is connected in between output terminal and the inverting terminal. Here in RF the current is also flown I in. How? Let's see the description of this expression. Let's see the expression for V out. The input impedance of the op amp is very high. Therefore, the currents entering into the two input terminal is very small, that is IB1 is equal to IB2 is equal to 0. We know that for the ideal op amp, the input impedance, that means R in or Z in, is tend to infinity. That is, the input impedance is very high. Hence, no current can flow through this terminal into the op amp. Therefore, the value of IB2 and value of IB1 is almost equal to 0 due to high input impedance. I hope you all understand this. And we know that the gain of the amplifier is given by AV is equal to minus RF upon R1 is equal to, and gain is equal to V0 upon V in, that means V out upon V in. Therefore, from this equation we can calculate the value of V0 as V0 is equal to minus RF upon R1 into V in. This is the very simple formula. Okay. Now, due to the virtual ground concept, we can write V1 is equal to V2. We know that the virtual ground concept tells us that the potential at V1 is equal to the potential at V2. But V1 is equal to 0 because it is connected to ground. Hence, V2 is also at the 0 potential, hence V2 has the value 0. I hope you all understand this concept. Let's see once again. Due to virtual ground concept, we know that V1 is equal to V2. But V1 is connected here. V1 is connected to the ground. Hence V1 equal to 0. Hence V2 is also equal to 0. Thus, the inverting terminal also is at ground potential and the entire voltage appears across R1. Let's see, the current flowing through R1 is I in is equal to V in upon R1. From this, we can calculate the value of V in. V in is equal to I in into R1. This is the simply conversion of this equation. I hope you all understand this. Now put the value V in is equal to I in R1 into the equation V out is equal to minus RF upon R1 into V in. If we put the value of V in here, then we get V out is equal to minus RF upon R1 into I in R1. Here R1 gets cancelled, hence we get minus RF into I in, like this. Okay. Therefore, we get the final equation V out is equal to minus RF upon Rin. This is the very simple derivation of the output equation. Now, from this equation, we can conclude that the equation indicates that the output voltage, that means V out, is proportional to the input current, that means I in. As the input current increases, voltage also increases, and vice versa. Thus, the circuit converts the input current into proportional voltage. I hope you all understand here the current to voltage converter. Let's see once again in short. Here we know that the input impedance of the op-amp 741 is very high, that means tends to infinity. That means there is no current can flow through this terminal. Hence, the value of IB1 and value of IB2 is nearly equal to 0. And this is the inverting type of configuration. The gain of the inverting configuration is minus RF upon R1, that is minus RF upon R1 is equal to V out upon V in. Therefore, from this equation, we can calculate the value of V out. V out is equal to minus RF upon R1 into V in. This is our first step. Now, in second step, we know that due to virtual ground concept, the V2 is equal to V1. But here V1 is connected to ground, hence V1 has the value 0. For that purpose, V2 also has the value 0. Due to which here V2 has the value 0, then the entire voltage is appear across the resistor R1. Now we can calculate the expression for current I in is equal to, we can write I in is equal to here V in upon R1. From this we can calculate the value of V in. Here V in is equal to I in into R1. Okay. Now put this V in is equal to I in R1 into V0 or V out equal to minus RF upon R1 into V in. Put the value of V in here. If we put the value RF upon R1 minus RF upon R1 into I in R1. Here R1 gets cancelled and we get minus RF into I in. This is our final output equation, which shows that the output voltage is proportional with the input current. I hope you all understand the expression for the current to voltage converter. Now let's see the applications of current to voltage converter. The current to voltage converter is used for sensing and measuring circuits through photocell or photodiode, etc. It is used in light intensity meter. It is used in digital to analog converter. These are the applications of current to voltage converter. I hope you all understand what is the current to voltage converter and its associated circuit. Thank you.